हाँ जी बच्चों, today we will discuss the two-phase method. We'll discuss the two-phase method. Let me have the same problem which we were discussing yesterday. I'm taking the same problem. The problem was of minimization type. Minimum z is equal to, this is given to us, minimum z is equal to x1 plus x2 subject to 2x1 plus x2 greater than equals to 4, x1 plus 7x2 greater than equals to 7, x1 comma x2 greater than equals to 0. This is the problem which we were discussing yesterday. I am taking the same problem. If any of the constraint is of greater than equals to type, wherever we are going to apply the big M method or H-Arness method or method of plenties. This is another option, the two-phase method is another option which is there. So today we will discuss the two-phase method. Whatever the results we are getting with the big M method, we will get the same result with the two-phase method. What were the results yesterday? If you recall, x1 was 21 by 13, x2 is equal to 10 by 13, z minimum was 31 by 13. As the word indicates, this is the two phase. As the word indicates two phase, we will have a phase 1, then we will have a phase 2. Here we will start with the infeasible solution. This is the beauty of the two phase method. Now first of all, look at the constraint 1. This is S1 is equal to 4, x1 plus 7x2 minus s2. Why? Because left hand side is of greater than the right hand side. That is why the slack variable has been subtracted from the first constraint by introducing s1, by introducing s2 in the second constraint. This was x1, x2, s1, s2 greater than equals to 0. If I put IBFS, when I am going to put IBFS, S1 is negative, S2 is also negative. Even though this is an infeasible solution, but there is no artificial variable. These are the slack variables. So we will introduce the artificial variable A1 and A2 where the constraints are getting failed. As in both the constraints, the values are negative, S1 and S2. So we have introduced as A1 and A2. And here if you look at here, I have changed it here. This is A1, A2 greater than equals to 0. And if you look at again IBFS, initial basic feasible solution, and the x1 is equal to x2 is equal to s1 is equal to s2 is equal to 0. What happened here? Look at here. Here the A1 is what? The A1 is, we are getting the value of A1 to be 4 and A2 is equal to 7. Now, what happened here? We will introduce a new objective function which will be of minimization type, minimum W. Whatever the variables are there, artificial A1, A2, instead of giving the plenty, we will add it like this one, A1 plus A2. So, what is there? I again mentioned it, the new objective function, this is the phase 1, new objective function. So what is the value of, you are getting the value of A1, A2, you are getting the value to be 11, because getting the value of 4 plus 11, the minimum value is 11. So minimum W is equal to A1 plus A2, subject to subject to, this was the constraint 2x1 plus x2 minus s1 plus a1 is equal to 4. x1 plus 7x2 minus s2 plus a2 is equal to 7. This is the feasible alternative x1, x2, s1, s2, a1, a2 greater than equals to 0. Now again we will solve the same problem. Now this is a minimization problem. Again we are going to do CSV. This we know, current solution variable. EI is the coefficient in the objective function of the incoming variable. Here it is x1, x2, s1, s2, then a1, a2, then b. From first constraint, and here it is Cj. Please don't convert it into the maximization problem, leave it as a minimization. This is 0 here, this is 0 here, 0 here, 0 here, 1, 1. This is the phase 1 of the problem which has been started. I have mentioned phase 1. Even you can mention it here, phase 1. Phase 1. There will be the two phases as the word indicate, because this is a two-phase method. So A1 having objective function 1, A2 from the second constraint the value is 1 in the objective function. If you look at here, here it is 2, 1, minus 1, 0, 1, 0, this is 4. Clear? This is 1, 7, 0, minus 1, 0, 1, 7. Another thing, this x1 and x2, it is 2 by 2 matrix. The coefficients are 2, 1, 1, 7. If you look at s1, s2, again this is a 2 by 2 matrix. Minus 1, 0, 0, minus 1. Again this is 2 by 2, but this does not represent, even though it is look like a 1, 1, but the coefficients are minus in sign. So this is not the unitary matrix. If you look at here A1, A2, this is 1, 0, 0, 1, this is the unitary matrix. When we will get the optimal result? We will always get the optimal result whenever the value of x1, x2 will be 0, 1 or 1, 0 or 1, 0, 0, 1. So when we will get the value of x1, if here it is x1, here it is x2, then 1, 0, 0, 1. If here it is x2, means here it will be 0, here it will be 1, here it is, if x1 is there, here it is 1, here it is 0. So it is like this one. So again solve it, Ej, corresponding elements, this is 3 here, this we have already discussed couple of times, minus 1, minus 1, 1, 1. So Cj minus Ej, minus 3, minus 8, this is 1, this is 1, this is 0, this is 0. And here it is, choose the most negative value, choose the most negative value, that is minus 8, because this problem is of minimization type. So in phase 1, you will always keep the problem to be of minimization type, irrespective of whether the problem is of minimization type, original problem, or is of maximization type. So this is for calculating theta, same procedure, b divided by the corresponding column, 4 by 1, 7 by 7. So choose the minimum value, this decides your outgoing variable, this decides your incoming variable. So intersection of incoming and outgoing decides the key element or the pivot element. So repeat the same procedure. So here what we have done in a Bingham method, we have, once we have A2 has been removed, means if A2 is going outside and x2 is coming inside. So please don't ignore A1 and A2. Continue with the A1 and A2 here in this one. In Bingham method, we have ignored it. So x1, x2, s1, s2, a1, a2, b. And a1 will remain as it is. A1 is coefficient having 1. It is a2 is going outside and x2 is coming inside, having coefficient 0 in the objective function. So what we are going to do, we are going to make this to be a unitary, the key element. Divide whole question by 7, 1 by 7, this is 1, this is 0, this is minus 1 by 7, clear? This is 0, this is 1 by 7, and here it is 1. Look at here. So these are the coefficients, 1 by 7, 1, 0, minus 1 by 7, 1 by 7, 0 minus 1 by 7, 0, 1 by 7, 1. Now, here it is what we are, here it is, this is, we have made it 1. Already there is a 1, so subtract 1 minus 1, 0, 2 minus 1, this is 13 by 7. Clear? This is 1 minus 1, 0, this is minus 1, this is 1 by 7, this is A1, 1, 0, 1 minus 0 is 1, this is minus 1 by 7, 4 minus 1, this is 3. Again this is Cj, 0, 0, 0, 0, 1, 1. Calculate Ej again. You can ignore this one. Look at the first row and multiply 1 into 13 by 7, 13 by 7, 1 into 0, 0, minus 1, 1 by 7, 0, minus 1 by 7. Now again calculate Cj minus Ej. This is minus 13 by 7, this is 0, this is plus 1, this is minus 1 by 7, this is 1, and here it is 1 minus minus, this is 8 by 7. Choose the most negative value because the problem is of minimization type. Clear? The problem is of minimization type. Choose the most negative. This has been chosen. Clear? So calculate this side your incoming variable. X1 is coming inside. And theta, to calculate theta, the b divided by the corresponding column. This is 21 by 13. 3 into 7 by 13. This is 7. So choose the minimum value, minimum 21 by 13 or 7. The minimum value 21 by 7. 13. So intersection of this one, this decides your key element or the pivot element. Now what is going outside? A1 is going outside and it is replaced by X1. Now do the iteration. When will be decided the phase 1 is over? I will discuss also that thing. So continue with this step. Now this is here, A1 is going out, X1 is coming inside, this is having coefficient 0 in the objective function, X2 0. So rest of the iterations means this pivot element has to be made 1. So multiply by 7 by 13. This is 1 here, this is 0 here, this is minus 7 by 13. So what is 7? This is 1 by 13. Clear? So again minus 1 by 13. This is 7 by 13. A1 is 7 by 13. Clear? This is minus 1 by 13. Clear? Minus 1 by 13. Theta is this b is 21 by 13. Clear? So is it okay so far? So probably this is what we get so far. This is 1, 0, minus 7 by 13, again 1 by 13, 7 by 13, minus 1 by 13, then 21 by 13. Now here, this rest of the elements in that column will remain 0. So this is 1 by 7, here it is 1. So divide whole question by 7. So difference is 0. 1 by 7 minus 1 by 7, this is 0, here it is 1. Is it okay so far? So divide by this and subtract it, this is 1 by 13. So divide it, so here it is this, minus 1 by 7, so minus 1 over 91, because divided by 7, 91 is LCM, minus 13 minus 1, minus 14 over, this is minus 2 over 13. Is it okay so far? This is okay so far. Next iteration, will go to the next iteration. What is A1? A1 is here, it is 0. This is minus 1 by 13 divided by 7. Now what is A2? This is 1 by 7. Clear? And here it is plus 1 over 91. Clear? 91 is LCM. 13 1 plus 14 by 91. This is 2 by 13. This is 2 by 13. Clear? So, another thing. Here it is 1. Here it is 21. Means 7 divided by 7, this is 3 by 13. So, 13 is LCM. 13 minus 3, this is 10 by 13. Is it okay so far? Yes, it is okay so far. Then calculate EJ. Now, another beautiful thing which you are getting here, x1, x2, here x1 is 1001 and a1, a2, now they are no more the unitary one. Similarly, s1, s2, they are also not the unitary one. So, we can expect we are reaching towards the optimal solution. Now, so far we have not reached 0, 0, this is 0, 0, 1, 1. Now, here it is 0, 0, 0, 0, 0, 0. Clear? Then Cj minus Ej. When you calculating Cj minus Ej, this is 0 here, this is 0 here, this is 0 here, this is 0 here, this is 1, where 1. When you are getting Cj minus Cj to be zeros and positive, this is the termination of phase 1. Means we'll move to the phase 2. We'll move to the phase 2. Means what happened in a phase 2? Look at here, this CSV, EI, X1, X2, S1, S2. Now you can ignore A1, A2. You can put a line on a A1 and A2. Is it okay so far? 7 by 13 minus 1 by 13 minus. So this is the termination of. Now we go to the phase 2. What happened in a phase 2? X1 and X2 will remain as it is. This Cj. What was your original function? The original function was x1 and x2. We have converted into maximum z dash, if you recall. Minus x1 minus x2. I am doing the same thing here. Minus 1, this is 0 here, this is 0 here. So, the coefficient is minus 1, minus 1. So, I continue with my previous practice. Minus 7 over 13, 1 over 13. This is 0, this is 1, this is 1 over 13, this is minus 2 over 13. Clear? So, what is the value of B as it is? This is 21 by 13, 10 by 13. Now, calculate EJ. When you calculating EJ, this is minus 1, this is minus 1. Here it is 7 by 13 minus this. This becomes 6 by 13 positive. Here it is minus, this is 1 by 13. When you are taking the difference of Cj minus Ej, this is 0, this is 0, this is minus 6 by 13, this is minus 1 by 13. And if you look at here, your Cj minus Ej are either negative or 0. The solution obtained is the optimal one. What is the optimal solution? We get the value of x1, I can put it here, x1 is equal to 21 by 13, x2 is equal to 10 by 13. And what is z minimum? Z minimum is equal to 31 by 13. Substitute the value. So, minimum value is 31 by 13. This is the same result which we got. I have already mentioned in the morning. X1, X2, 21 by 13, 10 by 13. This is the value. And if you look at here, this represents your y1 and y2. This represents your y1 and y2. And if you recall, I can rub it here and can put it another 1 minute. We will be able to qualify with this duality problem. So, same results. This y1, y2. What is this? Is the primal problem. What is the dual problem? This represents your duality. Dual problem is if your primal is of minimization function, this dual will be a maximum. Maximum W is equal to 4y1 plus 7y2. Subject to. What is the subject to? This is 2y1 plus y2 less than equals to 1, y1 plus 7y2 less than equals to 1, y1 comma y2 greater than equals to 0. And if you substitute here, this is 4, what is the value of y1? This is 6 by 13 plus 7 into 1 by into 7 into 1 by 13. If you add it, this is 24 by 13, this is 7 by 13, you got the answer 31 by 13. What is the duality theorem? The duality theorem, what is the duality theorem? Duality theorem states that your primal problem is equal to dual problem. The results of the primal problem is equal to the dual problem. We got 31 by 13, 31 by 13. So this states that this is the duality. Tomorrow we will discuss this as a problem. Here we will use the simplex method as well as the graphical method, because the number of variables are, in the next class we will discuss, we will take the same problem. This is our maximum w is equal to 4x1 plus 7y2 is 4y1 plus 7y2 subject to 2y1 plus y2 less than equals to 1, y1 plus 7y2 less than equals to 1, y1 y2 greater than. Here the number of variables are 2, so the best method is the graphical. We will get the results with the graphical, then we will solve because the constraints are of less than equals to type. The best method to solve this problem is the simplex method. So we will discuss in the next class. Thank you very much. If you have any doubt, you may ask me. Otherwise, today we discuss the two-phase method, where we are going to apply the big method. The two-phase is applicable only in that one. So there are phase 1 and a phase 2. We will start with the infeasible solution, then we will move to the, because A1, A2 be the part of the solution, means this is the infeasible solution. So once we are over with the phase 1, when we will decide the phase 1 is over? When Cj minus Cj, the values are zeros and positive. So this is the termination of the phase 1. We will start with the phase 2, same iteration we will do to start with the phase 2. It may continue with the another more iteration, or sometimes we may get the in the very first iteration of the phase 2 the optimal results. So here we get x1 is 21 by 30, x2 is 10 by 30, and for duality this s1 s2 this decides your with the same chime, this decides your the results of y1 is equal to 6 by 13 and y2 is equal to 1 by 30. This is always true. And moreover, if you look at here, this x1 and x2, this is a unitary matrix. That's it from my side. If you have any question, otherwise thank you very much.